everyone, this is Angeline Naypa from Group 9 MST 402, and for today I will going to discuss about the sensor board and modules. So sensor development boards and kits are small boards produced by integrated circuit device manufacturers to allow engineers to evaluate a sensor they manufacture. They are also used to accelerate development of products by enabling rapid prototyping of design. So all boards shares a common pin-out structure and can be mounted in either socket 1 or socket 2 of the carrier board repeats the same connections and opposing sockets. So the E-block carrier board provides ease of connections of the various signals of the sensor modules via the jumper selectors to the 9-way D-connector for upstream connecting to an E-block's programmer board. Depending upon the applications and the process port connected to the jumper settings may need changing from their default position to the use the patch wiring system. EB090 sensor board. The sensor board allows you to connect a range of digital or analog sensors to any of the I/O ports on the E-block's upstream board. In addition to the onboard photodiode and variable resistor, the board has two sockets for use with a range of sensor modules ranging from simple temperature sensor to digital compass and gyroscope. Features of sensor board: E-blocks compatible, extension range of plug-in sensor modules, onboard potentiometer, downstream D-type connector, compatible with most I/O ports in the E-block range, easy to develop programming code using flow code icons, vernier sensor module available to extend the range of external sensors. This is the board layout. So 1. 9-way D-type plug. 2. Patch system. 3. Patch selection jumpers. 4. Power screw terminals. Plus V equals the processor interface voltage. VPWR power supply normally 9 volts. 5. Potentiometer. 6. Power socket. 7. Light sensor. 8. Sensor module socket 1. 9. Sensor module socket 2. Sensor modules can be inserted either way round. 10. Processor interface voltage selector. So this is the EBM002 potentiometer. This board consists of the standard shaft rotary potentiometer that provides a linear voltage output ranging between the microcontroller power rails. This can be connected to analog to digital input of the microcontroller in order to provide a control value. So this is the EBM004 digital temperature. This board contains a LM75D digital temperature sensor that returns the temperature from an 11-bit ADC via an IC2-WAR interface to the microcontroller. Temperature resolutions of 0.125 degrees Celsius can be achieved with an accuracy of up to 2 degrees Celsius. So this is the EBM006 dual trimmer. This board provides two screwdrivers slotted preset rotary potentiometers. This output a linear voltage ranging between the microcontroller power rails, such that they can be connected to analog to digital inputs of the microcontroller in order to provide, for example, calibrations of other control values. So this is the EBM007 Rotary Encoder. So provides a rotary encoder with dual digital outputs that provide rotations and directions information. When connected to two digital inputs of a microcontroller, a digital path can be implemented to convert to digital values. So this is the EBM008 thermocouple. Provides a two-way screw terminal block for attaching a Type K thermocouple and provides a voltage output for use with an analog to digital converter input for conversions to temperature value. It also has an on-board thermistor and resistor potential divider for ambient temperature compensation reading. So this is the EBM009 gyroscope. This board contains an L3G4200D 3-axis digital gyroscope. Pitch rule and yaw parameter values are read via on IC interface. So next we have here EBM011 Hall effect. So the board has a Hall effect sensor that gives a digital output in the presence of a magnetic field in the region of 60 Gauss from a firmament, magnet or electromagnet, either north or south pole. So the next we have here EBM012 or PIR. So this passive infrared sensor gives a digital output and illuminates an onboard LED with a heat source movement is detected. So the next we have here EBM013 or touchpads. This board provides a two touch areas for use with capacitive sensing. Hence, two digital touch switches can be implemented. So next we have here EBM014 or touch slider. So this board provides a touch area for use with capacitive sensing. A sliding variable can be determined from the relative touch position along the slider. So we have here EBM015 magnometer. This board provides an LSM303DLHC sensor device which contains both a digital 3D accelerometer and a 3D magnetometer. All information is available via IC interface and such that a high-performance EPAS with numerous applications can be implemented. So next, we have here EBM016 or humidity. So this board uses the SHT21 humidity sensor and provides both digital relative humidity and temperature informations via IC interface. So next, we have here EBM018 or color sensor. The color sensor provides a digital conversions of incident light intensity and separate values for red, green, and blue components. Reflected light can also be measured via use of the onboard white light LED illuminators. So next, we have here EBM019 ultrasonic distance. So this board has both an ultrasonic transmitter and receiver. The transmitter is driven by an onboard 40 kHz accelerator which is enabled by the host microprocessor. The receiving sensor signal is amplified and provided as the analog signal to be processed by a signal channel ADC of the microprocessor by measuring the time delay between enabling a transmit pulse and receiving an echo. The distance of objects in a range of around 3 cm to 3 meters can be determined. So next we have here EBM020 infrared. So the infrared sensor board contains both an IR transmitter and receiver. The transmitter is enabled via a digital control signal and the receiver provides an analog output. By enabling the transmitter and reading the variable voltage output of the receiver, it is possible to measure the distance of a reflecting object in the region of 1 cm to 10 cm. EM021. So vernier socket. Vernier socket module allows the connections of a wide range of digital and analog sensors, ranging from the external temperature probes to heart rate monitors. And that's all for my discussion. Thank you so much for watching.